A plus B is less than or equal to A plus B absolute values is less than or equal to A absolute value plus B absolute value. These two will be used.
What last class?
Yes.
What was? Do we expand that out to A is equal to epsilon or something like that? What was it? A
is equal to 0. Do you want me to do it quickly? Okay, so
no. Well,
yeah.
That was we worked.
Oh no, we did. I don't remember now what happened with that, but it wasn't epsilon. It was something else that ended up being 0.
Okay, yeah.
No, not 0, but equal to something else.
Yeah, equal to A.
Yeah. Today, what's going to happen is two limits are going to become equal to each other because the difference between them will end up being equal to 0.
Okay.
Okay. All right. Very good. So I'm going to erase this. You should put this on your notebooks. Very good. All right. Let's go. Okay. So we have definition. I love definitions. I think I just love mathematics. Yeah, because I need to love something in my life.
Do let your daughter here.
Yeah, and her too. It's that kind of thing. Is a function. This is the simplest with very few anything function whose domain, this definition, it's kind of like maybe too simple, whose domain is the set of natural numbers, the set M of natural numbers. And Jake, stop me anytime. Tristan, anytime you have a question, stop me. Okay, so set of natural numbers we all know is this. 1, 2, 3, that's a 3 to infinity. And it's a function whose domain is the set of natural numbers. What the book doesn't say is that the range or the image of this function, when you stick a natural number, what you get out is, so let's just write that input equals some n that belongs to set of natural numbers, and output is let's call it a n that is in the set of real numbers.
Oh, real numbers.
Yeah. I love that. I just made that up. Get good at this shit. Okay. All right. So that's what a sequence is. Let's write one out. A, and let me do this in blue. So this is A1, comma A2, comma A3. I'm not going to go to 4. I should have, but I have problems, emotional. And dot, 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 dot. So this sequence can go to infinity. Okay. Another way to, and then this thing is called the formula, as well as this is the formula as well as the nth term. And I'm not going to go into, we can spend a whole class doing all kinds of things before we do the proofs, but that's not what this class is about. We'll let that, the unwashed can do that. There was something else that I forgot once I started talking about the unwashed. The formula spelling. Okay. Oh yeah. So in this textbook, Belding and Mitchell, when they say here's a sequence, they do this. They go these parentheses that you use for a set,
Mhm.
they put an inside. And then they go n equals 1. So that's the notation they use. And this is a sequence. Okay, all right.
So that means a certain one, or the first value of one of
Yeah,
n
yeah,
a
so-
of n.
Yeah, this is here.
Yeah.
And then this can go all the way to
A
infinity.
or
Yeah,
subscript.
8 that fell down on this side or something.
Yeah.
So that's infinity. So what are we dealing with? We're dealing with infinite sequences. Okay, now before we even move on, let's do two things. So should we put a sample sequence there? Yeah, why not, right? All right, so we have A and let's say, can we do this? Probably. Let's just use this. So we have 1, 2 squared, sorry, 3, I did the 4 finally. This is the formula. Okay, so just for the hell of it, so there it is, sitting there. Now, let's do a definition here, not a definition, but just quickly look at something. Convergent sequence. So what's a convergent sequence? A convergent sequence is a sequence that has a limit. But anyways, before we, so and we'll be looking at a convergent sequence starts to cluster around so this is the key idea here. Cluster around a limit A. And so as you can see, we're calling our sequences A sub n, and we're calling the limit not L in a function, but A, uppercase. Okay. And therefore does not go to the right forever. It's still an infinite sequence. It's just that on the number line, it's not going to go to the right forever. And let's look at what that means. So we're going to draw our sequence here. And then we could use, no, let's just use blue here. We have A1. Can you see A1? Good, okay.
Yeah.
A2. Let's do this again, sorry. I like A2 to be kind of like over here. A3. And then there's a threshold term.
Those numbers pass, right?
Yes, you have, yes, threshold term A uppercase N. Let's call it a threshold. Spell threshold. Threshold term. This is a term. After the threshold term, all the terms of the sequence are going to start clustering around a term that we're calling the limit of the sequence, a term that we are going to name as A. So A is a term. Let's call it the, okay, let's call it the term that is the limit. So what's going to happen? All the ANs are going to fall ANs. So all these vertical lines in the blue are ANs. Okay. And maybe there'll be some terms sitting here. Let's say A8. And maybe A9 over here. So before they start clustering around A, we have a finitely many terms. And this guy, sorry, oh, this was a massive mistake here. I usually like to put AN right next to it.
Okay.
So AN could be here. It could be here, but it's going to be within within epsilon. So AN could be right here, right before or right after, depending on the book, because you can say this, N is less than or equal to uppercase N. If you just do this, then N is not going to be within all the terms of the sequence after the threshold term. When you see this, we're talking about, when you see this notation, you're saying all the terms AN, all the terms with an S here, all the terms AN are going to be, sorry, that's what you were, greater than, okay, right? Greater than, yeah, all the terms AN, when you see this, this is actually AN that are greater than the term A uppercase N. Now, depends on the book. If the book puts this in here, then AN is the first term, A uppercase N is the first term that starts to cluster around, and the other ANs join up.
Yeah.
Okay, yes.
Yeah, but
And we'll be going over this again, but ask me the question, yes.
yeah, okay. So for the picture you drew,
Yes.
are those like two separate sequences or
No, just one sequences.
it can go past the threshold point then?
So let's put the threshold point right here.
Oh no, well, my bad. Wrong terminology. You can go past the cluster point.
Sorry, okay. 1 second. So this is, let's say, this is the AN. No, let me put AN right here. This is A. I'm gonna make this slightly bigger. So this is our A uppercase N, the threshold term. Okay, and now ask me the question.
It's just that I thought that I just didn't know it can go past A, right? Because they're all approaching it infinitely close. But yeah, okay.
Okay, so if it's a,
like I know.
So this is a generic term. What happens is after AN,
Yeah.
the sequence can jump back and forth.
Okay.
So one here, one goes 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 here, one goes, and they kind of do this in this cluster. If it's an increasing sequence, then it will only go, there'll be nothing here.
Okay, oh, okay, so,
This is the general sequence, a sequence in which the terms cluster on both sides of the limit.
can I write some?
Yes, yes.
Sure.
Mhm.
So what you're saying is that, so this is A event, this is included because of the side.
Yeah.
And there's gonna be A in +1, and here will be A,
Yes,
the big A
yes.
+2. Okay,
yeah,
so it's also, okay,
yeah, yeah.
appreciate it.
All of these are AN plus ones.
Yeah.
And then another plus one, another plus two, yeah,
Okay. no,
yeah,
no, no.
okay, very
We're
good.
good.
But I'm just calling them ANs, so
Yeah.
I think that's I should call them AN plus one. I should say A uppercase N plus one is, yeah, okay. So we could have also called, now that Tristan's pointed out, I could have labeled these as A uppercase N plus one terms with apostrophe and an S. Okay, all right, so next thing is we now know about this. They cluster within this distance, epsilon distance from A. This distance is epsilon, okay, on both sides. And is there anything else I need to talk about? No. Okay, so that is the convergence sequence. Let's draw on the blackboard a divergent sequence. So I'm going to erase this. And then also you can refer to my PowerPoint I sent out. Look at an example of a divergent sequence. A divergent sequence is a sequence that does not have a limit A, right? So goes on forever to the right or left, right? We're just doing right here. So you do see the difference here. Oh yeah, before we do that, this is very important. Here in the cluster, I'm going to put a note here. Infinitely, I'm writing infinitely many. Very important to remember that. And then outside of the cluster, to the left and the right, the terms are finitely many. Finitely many is that there are many terms, there are more than one,
But not, yeah, I know.
but not infinite. More than one, but they go on forever. Infinite. Okay. All right. You're like, what is that?
Well, no, I was thinking that makes sense to me in my head.
Yes.
Yeah. Threshold. Okay, I'll take it.
There will be no threshold term.
Okay, yeah.
Yeah,
Okay.
right. So we have A1, A sub 2, A sub 3, and A sub n, A sub n's, A sub n's. Very good, Sunnis. All right, Jake, you good? Any questions?
Yeah, no, I'm
You're good?